Hi, my name is Christian Janus, and I will be explaining the limit comparison test. Alright, to start out with this test is you use it when you have a function that you can't use direct comparison test, like the function 1 over n plus 1. Because that function is less than 1 over n, you can't use direct comparison test, because 1 over n diverges, and because it's bigger, it means you can't tell anything about 1 over n plus 1. So, the limit comparison test is as follows. The limit as n approaches infinity of b over n, or bn over a sub n equals L. And L must be positive and finite for this test to pass. And if L is equal to 0 and a sub n, which is the one that you choose, is convergent, then b sub n must also be convergent. If L sub n is equal to infinity and a sub n is divergent, then b sub n must also be divergent. So, using our test on this function, let's go over here and use it, and we have the limit as natural log, or as n goes to infinity, of 1 over n plus 1 over 1 over n, which becomes the limit as n goes to infinity of n over n plus 1. And as we get higher and higher in values for n, this function goes to 1, which is positive and a finite number, which means this this function has passed the limit comparison test. And if this test passed, then whatever a sub n, which is the function that we chose, and in this one it was 1 over n, whatever that does, b sub n must also do. And so we know that 1 over n, the series of that, must diverge because it is a p-series, and the p is less than or equal to 1, which means that it diverges. So 1 over n plus 1 must also diverge. And so this limit comparison test can be used in a series like the series of 1 over n plus 1 in comparison to this one, which is the series of 1 over n. And it can be used in that way to find convergence without having it to be necessarily being used the direct comparison test.